In exactly 6 hours and 23 minutes, something is going to hit Earth. NASA knows it's coming. They've been tracking it for 48 hours. It will slam into our planet's magnetic field with the force of 1 billion tons of TNT. NASA's prediction? Tonight, December 31st, 2025, could bring the most spectacular New Year's Eve light show nature has ever produced. But there's something unusual about this solar storm that has space weather forecasters on high alert.
Welcome back.
On Sunday evening, December 28th, at 10 PM UTC, something violent happened on the sun's surface. Sunspot region AR 431-7, a massive magnetic structure 10 times the size of Earth, erupted. The explosion released an M4.2 class solar flare, bright enough to temporarily blind satellites watching the sun. But the flare was just the warning shot. What followed was a coronal mass ejection, a billion-ton bubble of magnetized plasma torn from the sun's atmosphere and hurled into space. Direction? Straight toward Earth. That alone would be newsworthy. But here's what makes tonight different. At the exact moment this CME arrives, a second threat is approaching. A coronal hole, a canyon-sized tear in the sun's magnetic field, is rotating into position. From this hole pours a high-speed solar wind stream, traveling at 400 miles per second. Two separate solar events, arriving at Earth at the same time. Space weather forecasters call this a double impact scenario, and they're predicting something rare, G2 to G3 geomagnetic storms, possibly stronger. What does that mean for us? Before I show you what could happen tonight, I want to ask you something. How many of you remember the great Auroras of 1989? The March storm that knocked out power across Quebec for 9 hours? Or perhaps you witnessed the incredible October 2003 displays when auroras were seen as far south as Texas? Write in the comments, what's the furthest south you've ever seen the northern lights? Because tonight, you might break your record. NOAA's Space Weather Prediction Center released their latest models this morning. If the CME and the solar wind stream hit simultaneously, auroras could be visible tonight from Seattle, Minneapolis, Chicago, Boston, and even as far south as northern New York. For our viewers in Scotland, northern England, and southern Canada, this could be a spectacular show. But here's what fascinates me about this event. We've had 4 separate CMEs launch from the sun in the past 24 hours alone. Not just one, 4. The sun is entering what solar physicists call an active phase of solar cycle 25. Sunspot counts are at levels we haven't seen in nearly 20 years. And there's something else. The thermosphere, Earth's upper atmosphere, is unusually warm right now. The Thermosphere Climate Index shows readings of 22.05 times 10 to the 10th watts. That's warm on the scientific scale. When the thermosphere is warm, it absorbs more solar energy, which means geomagnetic storms can intensify more quickly. The 10.7 centimeter solar flux, a measurement of the sun's radio output, is at 196 solar flux units. For context, during solar minimum in 2009, that number dropped to barely 70.
The sun is waking up.
But here's the question nobody's asking. Why are we only getting 48 hours notice? In 2025, with all our satellites, all our solar observatories, all our computer models, why can't we predict these storms weeks in advance? The answer tells you everything about how little we truly understand our own star. Solar physicist Dr. Tamitha Skov, who tracks space weather daily, posted something intriguing 2 days ago. She noted that the CME from AR 4317 has an unusually strong magnetic field embedded in it. If that field is oriented southward, opposite to Earth's magnetic field, it will punch through our defenses like a knife through butter. If it's oriented northward, the storm could fizzle. We won't know until it arrives. 93 million miles of space, and we can't tell which direction a magnetic field is pointing until it's practically knocking on our door. This is what keeps NASA scientists awake at night. Not the CME we see coming, the one we don't. In 1859, the Carrington event, the largest solar storm ever recorded, gave Earth less than 18 hours warning. Telegraph systems burst into flames, auroras were seen at the equator, and that was before we had a power grid, before satellites, before GPS. If a Carrington-class storm hit us today, estimates range from $2 trillion in damage to complete collapse of modern infrastructure for months. Tonight's storm isn't that, not even close. But it's a reminder. So, what should you do tonight? If you're north of 45 degrees latitude, step outside after sunset. Look north. If you see a faint green glow on the horizon, you're witnessing something extraordinary. Particles from the sun, accelerated to near light speed, colliding with oxygen molecules in Earth's atmosphere 60 miles above your head. NASA's tracking this storm minute by minute. The Mars Reconnaissance Orbiter, the same spacecraft that gave us those incredible images of interstellar comet 3I Atlas just weeks ago, is monitoring the solar wind from its position 140 million miles away. The James Webb Space Telescope is protected, tucked behind its massive sun shield. And we're watching, waiting. At 2:43 p.m. Eastern, the plasma cloud arrives. By midnight, we'll know if this New Year's Eve becomes one for the history books. What do you think? Will tonight's aurora reach farther south than predicted? Have you ever seen the northern lights on New Year's Eve before? Drop your thoughts in the comments, and if you're planning to watch, let me know where you're observing from. Thank you for watching, and if you do see auroras tonight, you're witnessing something our ancestors saw as a sign from the gods. We know better now, but it's still magic. Until next time.